Hello there. In this video we're going to go over the proof of the midpoint connector theorem again. So what this theorem says is that if we take any triangle and draw in midpoints on a couple of the sides, and then connect them with a line, that line will be parallel to the third side and exactly half its length. So let's start with listing the givens. And a property of a midpoint is that it divides this length here in half. And we could do a longer, more elaborate proof of this too, using the segment addition postulate that midpoint defined as AM must be congruent to BM, and segment addition postulate says that AM plus BM is AB, and then through some substitutions get that 2-to-1 ratio there. But for this one, we're just going to do that over that is 1/2. That's going to happen on the other side too, but I'm actually going to sandwich the angle in between them. We're going to list this out for the big triangle. Actually, let's do the small triangle. It doesn't matter. Triangle MBN, not triangle, angle MBN is congruent to angle ABC. And that is the reflexive property. You could just list it as angle B for both of them, but I want to show in the letters that I'm really talking about what's going to become this one and this one. Could just say angle B is congruent to angle B. And then we got this proportion on the other side. So NB, remember I'm doing the short ones on top, that over that is 1/2. So here I have that side angle side proportion. So I'm going to have some similar triangles here. And that this little pink triangle MBN is similar to the blue triangle ABC by the side angle side similarity theorem, because I got those 1-to-2 proportions and the angles are matching up. Okay, so how does this help us? I need to show that it's going to be parallel, that line's parallel to that one. And to prove parallel lines, I need to know some angles. I'm going to approach this one from the left-hand side, so looking at this angle and this angle, that angle A is congruent to angle BMN. I have to list the 3 letters because if I just say angle M, it's unclear, do I mean this one or do I mean this one? So we have those angles are congruent to each other because of corresponding angles of similar triangles are congruent. We knew that the pink triangle was congruent to the blue one, and those are the parts that match up with each other. And this helps us prove the first part because those angles are created by these 2 lines and this as the transversal. So upper right, they're congruent. Those lines MN and AC must be parallel by the parallel line postulate. So that gets us the parallel part. We're halfway there. We got that one already. Now we need to show that this length that we created, and here MN, is parallel to the third side and half its length, so that this is half the length of that. And we're going to do that again using the similarity. We already got that 1-to-2 ratio there. We just need to list all of the parts. We had those 2 parts, so it's the left and the right. Now I just need the bottom, which is MN over AC, and I know all of those ratios are equal to each other because corresponding sides of similar triangles are proportional. And then I can just look at these previous parts up here, perform a substitution to show MN over AC is 1/2, and that's essentially it. I could wrap things up with a little bit of multiplication. So multiply through by AC on both sides, and we've got MN is 1/2 AC, and that shows that that length is half the length of the other side we wanted. So we got both of the parts. We showed that the lines were parallel to each other, and that is half the length of that. Thanks for watching. Characteristic Scholarship for Life.